What are the odds that a cosmic wanderer and the Earth itself would seem to move in sync? In late September, the interstellar visitor 3 Atlas flared with strange brightness just as Venezuela was struck by two massive earthquakes, both within 24 hours of each other. On one hand, we're told these events belong to different worlds, one in the depths of space, the other deep beneath the crust of our planet. Yet the timing is so precise, so unnerving, that it feels less like chance and more like a pattern emerging from the shadows. Was it coincidence, or something written into a larger cosmic script? Tonight, we'll investigate the physics, the eerie timing, and the whispers of a universe that may be more connected than we realize. Stay with me until the end, because the answers may reshape how we see both Earth and the sky above. The September chain of events. What are the odds that the Earth itself would convulse twice in a single day, just as a wandering interstellar visitor flared with unexplainable brilliance in the sky? In late September, Venezuela endured a terrifying sequence that locals described as a nightmare replay. First came a quake measuring 6.1 on the Richter scale, deep beneath the country's northern coastal bedrock. Buildings swayed, glass shattered, and social media lit up with real-time footage of frightened residents rushing into the streets. Barely 24 hours later, before nerves could settle, another shock ripped through the same region. This time, a 6.3 magnitude tremor that rattled the same towns and left seismologists stunned at the statistical improbability. It was strange enough on its own, but the timing was what elevated this into something more than a regional disaster. Because while Venezuela trembled, eyes across the world were already fixed on the heavens. 3I Atlas, the newest interstellar object to enter our solar system since Oumuamua and Borisov, was behaving in ways that contradicted expectations. Its coma glowed larger than predicted, its trajectory showed faint but puzzling anomalies, and its brightness surged at moments when no simple explanation sufficed. Scientists were still debating its nature, icy comet, rocky fragment, or something stranger, when the quake struck. The story begins with coincidence. A pair of earthquakes unfolding in such rapid succession is rare, though not entirely unheard of. Earth's crust moves in chaotic ways, and aftershocks sometimes rival the main event in strength. Yet here was something different. Two quakes, similar in magnitude, separated by just one day, with epicenters close enough to feel like echoes of one another. Geologists noted that the subduction zone off Venezuela's coast is active. Yes, but this precise double strike raised eyebrows, and as the scientific reports came in, another layer of mystery unfolded above the atmosphere. 3 Atlas was already making headlines for its strange green glow, caused not by the usual cyanogen emissions, but by an unusual carbon dioxide ratio that seemed almost too pure, too stable to fit standard models. Then came the solar storm. Just days before the Venezuelan tremors, a coronal mass ejection from the sun swept through the solar system, brushing past Earth's magnetosphere and traveling outward into space. Instruments recorded heightened geomagnetic activity, auroras danced unusually far south, and whispers of strange coincidences circulated. The storm, astronomers noted, passed close enough to 3I Atlas to interact with its coma. Was that why its brightness spiked? And so, as Venezuela staggered through disaster, a narrative began forming. Was there a connection? Mainstream science insists there is no causal link between cosmic visitors and tectonic tremors. Earthquakes are driven by the slow grind of plates beneath our feet, not by passing objects millions of kilometers away. But history shows us that humanity has always looked skyward when the ground shakes. Ancient records describe comets as omens of doom, harbingers of floods, wars, and yes, earthquakes. Superstition most dismiss. Yet when timing appears this precise, even skeptics begin to wonder. The first quake struck at mid-morning, rippling outward with enough force to topple older structures and crack roadways. It was terrifying, but survivable. Emergency responders fanned out, counting injuries, securing power lines, and urging calm. Then, as night descended on an anxious population, many feared aftershocks. They did come, but not the small tremors expected. Instead, the following afternoon brought a quake even stronger, unleashing panic in neighborhoods still littered with rubble. It was like the earth was mocking us, one resident said. We survived once, only to be tested again. Meanwhile, in observatories across the globe, researchers puzzled over the brightness curve of 3 Atlas streamed in, showing a surge in luminosity that didn't correspond neatly with its distance from the sun. Some suggested volatile outgassing, others argued for fragmentation events, but the numbers resisted clarity. What unsettled many was the timing. Brightness spikes appeared eerily aligned with the window of Venezuela's tremors. Pure coincidence? Almost certainly. Yet, when the human mind lays these events side by side, a deeper unease takes root. The earthquakes were localized, but their psychological effect rippled globally thanks to instant news feeds. Videos of collapsing walls and frightened families spread online just as headlines about the interstellar comet's glow appeared beside them. For viewers scrolling their screens, the juxtaposition was unavoidable. Sky and ground, fire and stone, two realms colliding in perception. It's here that the seeds of mystery sprout, when unrelated events align so perfectly in time that they feel orchestrated. Consider this: in the same month, astronomers also reported nova eruptions visible to the naked eye, rare in their sudden brightness. The sun itself spat out more flares than expected as solar cycle 25 approached its peak, and in Venezuela the crust gave way twice in a day. Pile these threads together and the narrative almost writes itself. A month of cosmic upheaval mirrored by terrestrial unrest. But is it narrative bias, or is there something real beneath the pattern? Scientists urge caution. There is no physical mechanism, they argue, by which a cometary visitor millions of miles away could rattle tectonic plates. No electromagnetic surge strong enough, no gravitational tug measurable. And yet, skeptics face their own challenge, explaining the sheer improbability of timing. Because if coincidence explains it, the odds feel uncomfortably long. The September chain of events will linger not only in geological reports and astronomical journals, but in collective imagination. Humans are pattern-seeking creatures. We look at randomness and see meaning. Still, sometimes the patterns are undeniable. 2 quakes in 24 hours, an interstellar anomaly glowing green in the skies, a solar storm sweeping past all at once. One might dismiss each in isolation. Together, they feel like a drumbeat, a signal, faint but insistent, that the universe is not as disconnected as textbooks suggest. This is the strange power of timing. When unrelated forces collide in our perception, they create a narrative weight stronger than data alone. Venezuela's quakes will be studied for their seismic signatures, 3 Atlas for its chemical quirks, and the solar storm for its plasma streams. But in the court of human imagination, they belong to the same story. A story of September when earth and sky seemed to whisper in unison. And as the dust settled, both literally and figuratively, a single question echoed louder than the tremors themselves. Was it coincidence or something else entirely? Twin quakes in one region. When the ground trembles once, people brace themselves for the aftershocks. But when a second quake, nearly equal in magnitude, strikes within 24 hours of the first, in the same stretch of land, the event takes on a haunting symmetry. Venezuela, a nation already perched on one of Earth's most volatile tectonic boundaries, suddenly became the epicenter of one of the strangest geological sequences of recent years. 2 quakes, separated by little more than a day, hammered the same coastal region, shaking homes, unsettling lives, and raising uncomfortable questions about whether these were ordinary tectonic slips or part of something more elusive. The first tremor measured 6.1, strong enough to knock goods from supermarket shelves, crack plaster walls, and send crowds rushing into open squares. People in Caracas and other urban centers described the sensation as a rolling wave, not a sharp jolt. Those who had lived through quakes before recognized it immediately, but what unnerved many was its duration, long enough to make time feel suspended, long enough for fear to swell into dread. Then, as reports confirmed no catastrophic collapse, there was a sigh of relief. This was survivable. This was a quake they could move past. But earthquakes are rarely polite enough to come alone. Most seismologists warn that aftershocks, sometimes significant in their own right, can follow. Yet the quake that arrived the next afternoon defied expectations. Instead of a weaker echo, it registered 6.3, a fraction stronger than the first, and equally disruptive. Its epicenter was again located off the coast, within a zone of subduction where the South American plate grinds against the Caribbean plate. The repetition was eerie, like a mirror image stamped onto the Earth's crust. In coffee shops, homes, and offices, people froze in disbelief. It was déjà vu, one resident remarked. The same shaking, the same fear, almost like a cruel trick. Geologists quickly weighed in, calling the pairing unusual but not unprecedented. Venezuela lies within a tectonically complex zone where multiple microplates converge. Stress builds silently for years, even decades, until it suddenly releases in violent bursts. Sometimes that release comes in sequences, 2 or more quakes in close succession, triggered by the redistribution of stress. Still, to the public, the explanation felt unsatisfying. 2 quakes of such magnitude, so close in time and space, gave the unsettling impression of a script written by unseen hands. The rarity of this double strike is what keeps it lodged in memory. Statistically, the odds of 2 quakes above magnitude 6 hitting the same region within 24 hours are low. Aftershocks usually diminish in intensity. Rarely do they rival the main shock, let alone surpass it. The Venezuelan sequence, therefore, raised the specter of a larger pattern. Could the crust have been primed for a cascading rupture? Did the first quake weaken fault lines just enough to trigger the second? Or was there an external nudge, something in the environment, atmospheric or cosmic, that lined up with these tectonic convulsions? Local residents, shaken both physically and psychologically, turned to their own interpretations. Some drew parallels with past disasters, recalling the devastating 1997 Cariaco earthquake that killed more than 80 people. Others turned to religion, filling churches to pray against further calamity. And still others looked skyward, noting how unusual the heavens appeared that same week. Social media buzzed with images of auroras from distant latitudes and of the glowing green visitor, 3I Atlas, which dominated astronomy feeds. For people already in a state of heightened fear, the overlap felt almost supernatural. From a scientific perspective, the Venezuelan quakes fit within the language of plate tectonics. Subduction zones, especially where smaller plates interact, are prone to complex sequences. Stress does not always release in a neat, singular event. It can trigger a domino effect. But what gives this pair its sinister edge is the symmetry. Earthquakes are chaotic, random bursts of nature. Yet here was a sequence that looked too deliberate. 2 tremors, nearly identical in size, striking in rhythm, like twin beats on a drum. Patterns like these often send researchers digging through historical records. Were there other moments when paired quakes struck in Venezuela? Indeed, there were, but rarely with such precision. The region's seismic history includes scattered examples of clusters, but usually separated by days or weeks, not a clean 24 hours. In fact, worldwide studies of twin quakes suggest they are rare enough to be memorable. In 2012, northern Italy experienced a similar double strike, 2 large quakes within days of each other that killed dozens. In 1999, Turkey endured devastating twin shocks months apart, but each powerful enough to collapse cities. These examples remind us that sometimes the Earth does not release all its fury at once. Sometimes it parcels it out, as if unwilling to let go of its hidden energy in a single breath. The Venezuelan quakes, however, stand apart for another reason. They coincided with a cascade of other anomalies. Around the same days, the sun unleashed coronal mass ejections, filling Earth's magnetosphere with charged particles. Astronomers noted unusual behavior from 3I Atlas, its coma brightening in ways no one could quite explain. And to the public, living through 2 consecutive days of fear, the convergence of cosmic and terrestrial turmoil was impossible to ignore. Psychologists remind us that humans are wired for pattern recognition. It is a survival trait, born of the need to detect threats quickly. We see faces in clouds, shapes in shadows, and connections where none may exist. Yet there is also the question, what if, occasionally, the patterns we perceive are not illusions? What if timing does matter? Science may dismiss the notion that comets or storms could spark tectonic shifts, but absence of evidence is not evidence of absence. Research into earthquake triggers has uncovered correlations with tides, rainfall, and even atmospheric pressure changes. Could it be that in rare, poorly understood ways, cosmic influences nudge an already unstable fault over the edge? The Venezuelan double quake sequence sits at this crossroads of science and speculation. On one side, the established laws of plate tectonics, the grinding inevitability of geological stress. On the other, the tantalizing possibility that timing with cosmic phenomena is not meaningless. This duality is what makes the story resonate. To geologists, it is an anomaly worth studying. To the public, it is a mystery that whispers of a hidden order. In the days that followed, Venezuelans lived with an undercurrent of fear, waiting for a third strike. Scientists deployed portable seismographs to track aftershocks, hoping to model stress changes across the faults. The media replayed footage of swaying high-rises, cracked highways, and terrified families huddling outdoors. And meanwhile, in quiet corners of the internet, theorists stitched the quakes into a larger cosmic narrative, linking them to Three-Eye Atlas, to the sun's unrest, and to a sense that September itself was a month out of balance. Whether coincidence or connection, the twin quakes left a mark. They reminded us how fragile our ground really is, and how easily nature can blur the line between randomness and design. Earthquakes are unpredictable by their very nature, yet when two arrive like twins, synchronized, balanced, and chillingly alike, they demand more than a shrug. They invite us to wonder, is the Earth simply cracking under its own weight, or is it echoing to a rhythm set beyond the sky? And as the dust settled and the people of Venezuela began to rebuild, that question lingered, not only in the streets they walked, but in the minds of all who watched from afar, unsettled by the eerie symmetry of two quakes in one region, two reminders that the ground beneath us is never as stable as we wish to believe. Three-Eyed Atlas in the spotlight. When news first broke of a new interstellar object entering our solar system, the astronomical community braced for another wave of curiosity, like the one that followed Oumuamua in 2017 and Borisov in 2019. But few expected that the latest arrival, designated Three-Eye Atlas, would prove to be even stranger than its predecessors. This elongated visitor, racing along a hyperbolic path that guarantees it will never return, came wrapped in mysteries from the moment it was discovered. Its glow was brighter than calculations suggested, its trajectory appeared subtly off-kilter, and its chemical fingerprint did not neatly match anything in existing cometary catalogs. Within weeks, Three-Eye Atlas wasn't just an object of interest. It had become the centerpiece of debate, speculation, and a flood of late-night telescope sessions around the world. The I in its name stands for interstellar, placing it among a category that is still vanishingly rare. Oumuamua was the first, Borisov the second, and now Atlas the third. Three known visitors from the stars, each carrying its own bag of anomalies, and each leaving scientists both thrilled and uneasy. If Oumuamua was strange for its shape and unexplained acceleration, and Borisov for its comet-like yet chemically unusual properties, then Atlas arrived with a reputation for defying expectations almost from the start. Observers quickly noted its vibrant green glow, a hue not uncommon in comets, but puzzling in this case. Standard explanations would point to cyanogen or diatomic carbon molecules fluorescing under solar radiation. But spectroscopic analysis suggested a composition heavy in carbon dioxide, too heavy, perhaps, to make sense. Why would an interstellar object formed in an entirely different stellar nursery carry such a pristine and dominant reservoir of CO2? Its trajectory only deepened the puzzle. Unlike Oumuamua, which darted through the inner solar system at a steep angle, Atlas traced a path that would carry it perilously close to both the Sun and, later, Mars. Early predictions suggested it might brighten to naked-eye visibility, sparking excitement among amateur astronomers. Yet as its light curve was tracked night after night, inconsistencies emerged. The brightness rose in sudden surges rather than in the steady climb expected of a comet approaching perihelion. At times, the glow seemed to pulse, as though the object itself were flickering with some hidden rhythm. Instruments disagreed on the exact size of its coma, with some estimates suggesting a gaseous envelope nearly half the diameter of the Sun. That figure sounded absurd, but data from multiple observatories hinted it might not be an exaggeration. Then came the solar storm. Just days before Venezuela's twin earthquakes rattled the crust, the Sun unleashed a coronal mass ejection that brushed Earth's magnetosphere and continued outward. Space weather models indicated that the plasma cloud would cross paths with Atlas's trajectory. Observers watched closely, and soon after, the comet flared in brightness. Was this the expected result of charged particles striking volatile gases, or was something more unusual unfolding? Some scientists urged caution, pointing out that cometary activity often spikes unpredictably. Others admitted, with uncharacteristic bluntness, that the timing was uncanny. Mainstream explanations began to strain under the weight of anomalies. The coma's symmetry was off. Its anti-tail, a phenomenon in which dust trails forward toward the sun rather than away from it, was unusually pronounced. Spectroscopic readings varied depending on the instrument, some showing excess hydrogen, others showing little at all. And the object's rotation rate, another mystery, remained elusive. Comets typically tumble or spin, revealing periodic changes in brightness as their surfaces rotate. Atlas, however, seemed too stable, too smooth, as if its entire surface were venting in unison. Speculation inevitably followed. Was this simply a frozen relic of a distant system, carrying chemical recipes unknown to our own? Or could it be something more complex, a fragment of a disrupted planet, or even, as fringe voices whispered, an engineered object? Oumuamua had already triggered headlines about alien probes thanks to its inexplicable acceleration. Atlas, with its steady glow and strange composition, was fertile ground for similar speculation. A few researchers, while careful to avoid sensationalism, admitted that natural explanations are not yet sufficient. The mystery deepened when amateur astronomers began to share their observations online. Many reported oddities in the coma's shape, structures that looked less like random dust clouds and more like filaments, as if woven. Some claimed to see shadow-like objects drifting near the core, raising questions about whether the comet was fragmenting or accompanied by a swarm of smaller bodies. Professional observatories confirmed some of these detections, noting dark companions in the vicinity. Whether these were fragments or merely shadows of dust clumps remained unresolved. Meanwhile, the public fascination grew. News outlets picked up on the green glow and the interstellar tag, branding Atlas as a cosmic visitor, unlike any before. Social media amplified speculation, with theories ranging from doomsday scenarios to ancient prophecies about green stars in the sky. Some pointed to petroglyphs and manuscripts that seemed to describe serpents of light or emerald stones in the heavens as omens of upheaval. To many, it was poetic coincidence. To others, it was more than coincidence. It was continuity, the latest entry in a record of celestial portents stretching back millennia. Scientists, caught between hard data and public imagination, tried to balance their language. We are still gathering observations, they repeated, and Atlas may yet behave like a normal comet. But their careful words could not hide the undertone of unease. Why was the brightness curve so erratic? Why did the energy output seem disproportionate to the object's estimated mass? Why were some instruments detecting molecular signatures that shouldn't exist in that abundance? Every anomaly attracted new eyes. The James Webb Space Telescope turned its gaze toward Atlas, gathering infrared spectra that hinted at unfamiliar organic compounds. Ground-based polarimetry studies suggested dust grains larger than expected, scattering light in peculiar ways. And whispers circulated about unpublished data, glimpses of energy spikes that didn't fit the cometary profile. As Atlas drew closer to perihelion, anticipation mounted. Would it survive its brush with the sun, or would it fragment like so many comets before it? Some predicted a spectacular breakup, scattering shards across the inner solar system. Others warned it might hold together, raising questions about its resilience. If it did survive, its close pass by Mars promised another chapter of scrutiny. Cameras orbiting the red planet were poised to capture high-resolution images, perhaps settling the debates, or perhaps opening new ones. For the people on Earth, watching from afar, Atlas became more than a comet. It became a symbol of timing, of convergence, a green wanderer flaring in the skies as the ground itself shook, as the sun hurled plasma storms, as novas lit up distant constellations. It was impossible not to see it as part of a bigger tapestry. The Venezuelan quakes gave the story human urgency, while Atlas gave it cosmic scale. Together, they wove a narrative of Earth and sky echoing each other in September's uncanny sequence. And yet, even stripped of coincidence, Atlas in isolation remains a mystery worth losing sleep over. An object born around another star, crossing into our system for the first and only time, glowing with unexplained chemistry, behaving with unnerving stability. It demands attention not just for its scientific puzzles, but for what it represents. A reminder that the universe still delivers surprises, that our models are not final, and that reality often outpaces imagination. As it streaks past the sun and onward into the abyss, 3 Atlas will leave behind only data, debates, and perhaps a trail of speculation that lingers long after its glow fades from our skies. But while it is here, while it burns green in our telescopes and fills our headlines, it holds us in its spotlight. And in that spotlight, we are forced to ask not just what it is, but what role it plays in the uncanny sequence of September, a visitor, a coincidence, or perhaps a signal written across the stars. The solar storm Sideswipe. In the week leading up to Venezuela's twin earthquakes, the sun erupted in a display of power that reminded scientists why we call it a living star. A coronal mass ejection, one of those vast plasma clouds capable of spanning millions of miles, burst forth from the solar surface and surged through the solar system. The Earth caught the edge of it, enough to trigger geomagnetic storms, brilliant auroras, and minor disruptions in radio communications. But Earth wasn't the only target. Calculations showed that the same CME swept outward along a trajectory strikingly close to 3I Atlas, the interstellar visitor already under scrutiny for its bizarre glow. What happened next gave this storm an almost mythic quality. As the solar wind tangled with Atlas, the comet flared in brightness, igniting debate that still hasn't settled. Coronal mass ejections are not rare. The sun cycles through phases of activity, and solar cycle 25 has already shown itself to be volatile. But timing matters. This CME arrived in the last week of September. At the precise moment, Earth itself seemed restless beneath Venezuela's crust. Coincidence, say many scientists. Yet for observers steeped in the rhythm of cosmic phenomena, the sequence felt too uncanny. The sun lashes out, Earth trembles, and the interstellar wanderer responds with a sudden surge of energy. It reads like choreography. The interaction between comets and solar storms has precedent. Charged particles can excite gases in a comet's coma, producing temporary brightening. Dust tails can distort, elongate, or even flip direction when battered by the solar wind. Still, Atlas's reaction stood out. Brightness changes were sharper than expected, recorded almost simultaneously by multiple observatories across continents. Its coma expanded rapidly, and an unusual structure appeared, a sunward-pointing anti-tail that seemed to defy the physics of solar pressure. To astronomers, this was a treasure trove of data. To the wider public, it looked like a cosmic signal. Reports of auroras at lower latitudes than normal added to the aura of mystery. From Scandinavia to Canada, from Scotland to the northern US, skies glowed in shades of green and violet, echoing the eerie emerald hue of Atlas itself. The symbolism was hard to miss, Earth's atmosphere shimmering in resonance with a comet born beyond our system. For people watching both the sky and the news of Venezuela's quakes, the convergence painted a picture of forces aligning in ways that science struggled to explain neatly. And yet, science did try. Researchers pointed to the natural chain of cause and effect. The sun ejects plasma, it strikes Earth's magnetosphere, and any comet in its path, auroras intensify, comas flare. Nothing supernatural, nothing engineered. But even in those explanations lay seeds of doubt. Why did Atlas brighten so much more than expected? Why was its anti-tail so pronounced? Why did the flare line up so closely with Earth's seismic unrest? These were the questions left hanging in the air, unanswered, tantalizing. The CME itself was classified as moderate by space weather standards, not the kind of monster storm that could cause continent-wide blackouts or cripple satellites. But even moderate events can have ripple effects. Earth's ionosphere rippled with disturbance. Navigation systems briefly wavered. And Atlas, sitting millions of kilometers away, seemed to respond like a bell struck by a hammer. The flare in its coma was sharp, sudden, and unmistakable. Some scientists speculated that hidden volatiles beneath its crust were exposed, venting gas under the CME's assault. Others suggested its composition, dominated by carbon dioxide, made it unusually reactive to solar radiation. Neither explanation fully accounted for the scale of its response. Speculation grew louder when amateur astronomers began reporting odd visual features in the days following the CME. Some described a halo-like structure around Atlas, brighter on one side than the other, as though the comet were reflecting or emitting energy in a directional beam. Others noted faint, dark specks moving near the object, fueling theories that fragments had broken off under the storm's stress. Fragmentation is common among comets, But the timing here, so soon after the solar blast, added fuel to whispers of cosmic choreography. Meanwhile, in Venezuela, recovery crews worked through rubble, tending to communities rattled by back-to-back quakes. For them, the sun's outburst was far removed, another headline from the realm of astronomy. Yet online, the connections formed almost instantly. Videos of auroras appeared beside videos of trembling buildings. Threads speculated whether the same cosmic storm that brushed Earth had somehow shaken the planet, even if only metaphorically. Scientists pushed back, pointing out that the energy required to trigger tectonic quakes is vastly greater than anything a CME could deliver. But that did little to stem the tide of public fascination. Historical parallels did not help. In 1859, the Carrington event, a massive solar storm, fried telegraph systems worldwide and coincided with reports of unusual seismic activity in some regions. Though no causal link was ever proven, the anecdote persists, cited whenever the sun and Earth seemed to misbehave in sync. And so, September 2025 slid neatly into that lineage, another moment where solar storms and terrestrial unrest overlapped too precisely to ignore. Within the scientific community, debates quietly sharpened. Some researchers argued that the Atlas flare could teach us about interstellar comet chemistry. Others suggested the event underscored how little we truly know about the ways comets interact with space weather. And in more speculative corners, a few dared to suggest the possibility of deliberate timing, that Atlas, or whatever forces shaped it, had somehow been waiting for a solar storm to reveal its true nature. These whispers rarely reached formal journals, but they circulated in late-night conversations at conferences, fueling the aura of mystery. The CME's passage was eventually logged, analyzed, and filed like countless others. Its data joined archives of solar activity stretching back decades. But Atlas refused to be filed away so neatly. Every telescope that turned toward it recorded more anomalies. Its brightness would not settle into predictable curves, its coma seemed too structured, and its chemistry defied expectations. The solar storm had, in effect, pulled back the curtain for a moment, exposing a deeper strangeness. For those attuned to patterns, the timing was irresistible. Within a single week, the sun erupted, Earth quaked twice in a day, a nova blazed in a nearby constellation, and Atlas flared green against the black. To dismiss it as coincidence felt like willful blindness. To embrace it as connection felt like heresy to conventional science. Most people found themselves caught in the middle, drawn to the narrative of synchronicity, but wary of the leap into speculation. And yet, even the skeptics admitted one thing. The solar storm's sideswipe was a turning point. It marked the moment when Atlas shifted from being just another interstellar curiosity to something larger, something threaded into the story of Earth itself. The comet was no longer a distant traveler. It had interacted with the most powerful force in our solar system and responded in ways we still do not fully understand. That interaction, lined up with human-scale disaster, left a scar on the collective imagination. The sun will continue to rage, as it always has. Comets will continue to flare under its breath. Earth will continue to shake along fault lines that predate humanity. But when all three align in a single week, in ways that seem too symmetrical to dismiss, we are forced to reckon with possibility. Was the solar storm merely a sideswipe, a natural brush of plasma on a lump of frozen gas? Or was it a moment of revelation, a reminder that the universe may contain patterns we have not yet learned to decode? In that blinding flash of solar energy against Atlas's emerald glow, one truth stood clear. We were watching a dance of forces far older and grander than ourselves. And for a brief moment, it felt as though the choreography had been written not in chance but in deliberate strokes across the sky. Electromagnetic Earth. Every earthquake begins with the grinding of rock beneath our feet, but some researchers insist the story doesn't end there. For decades, a quiet but persistent debate has played out in scientific circles. Could Earth's electromagnetic environment play a role in triggering, amplifying, or even predicting seismic events? It is a theory that sits at the edges of mainstream geology, embraced by some, dismissed by others, but never entirely silenced. And when Venezuela was shaken by two powerful earthquakes within a single day, at the very same moment, the planet was bathed in geomagnetic disturbance from a solar storm, the theory resurfaced with renewed urgency. Earth is more than just solid rock and shifting plates. It is wrapped in invisible fields of energy, the magnetosphere, the ionosphere, and the subtle electric currents that course through the crust itself. The magnetosphere shields us from solar radiation, bending streams of charged particles into auroras. The ionosphere, a charged layer of the atmosphere, swells and ripples under geomagnetic storms. And deep below, in the lithosphere, piezoelectric effects from stressed rocks may produce faint electromagnetic emissions before a quake. This tri-layered system, above at the surface and below, forms what some call the electromagnetic Earth. And it is here, in the intersection of tectonics and space weather, that speculation thrives. When the solar storm sideswiped Earth in late September, magnetometers around the world registered sudden disturbances. Auroras flared farther south than usual. Airlines adjusted polar flight paths to avoid radiation spikes. The storm was not the most severe in history, but it was enough to remind us of the sun's power. At the same time, seismographs in Venezuela recorded the first quake, a 6.1 magnitude event. The next day, another struck, this time 6.3. On paper, the two systems, geomagnetism and seismology, remain separate. Yet the timing invited questions. Could the electromagnetic surge from above have coincided with stresses below, tipping the scales toward rupture? The idea is not new. For centuries, people have reported strange phenomena before major quakes. Flickering lights in the sky, animals acting erratically, even strange electrical sensations. Modern seismology tends to file these as anecdotal, but in recent years, a growing body of evidence suggests there may be something to it. Satellite measurements have occasionally detected ionospheric anomalies hours before large quakes. Ground-based sensors have recorded electromagnetic pulses in regions that later erupted in seismic activity. These pre-quake signals remain controversial, but their existence cannot be fully denied. Venezuela's twin quakes reignited these debates. In the days before the events, researchers monitoring Earth's electromagnetic field noted irregular fluctuations. Some chalked it up to the approaching solar storm, but others pointed out that the disturbances seemed localized above South America. Could the sun's outburst have primed the ionosphere, destabilizing it just enough to amplify subtle tectonic signals? Or conversely, could stress building in the crust have disturbed the ionosphere, which then resonated more strongly under the solar storm's pressure? The truth remains uncertain, but the questions grow harder to dismiss. Skeptics remind us of the scale mismatch. The energy released in a moderate solar storm is dwarfed by the tectonic forces that drive earthquakes. The grinding of plates involves unimaginable stresses. Billions of tons of rock locked in collision, shifting after decades or centuries of buildup. How could a few charged particles from the sun influence that? Yet proponents argue that the sun does not need to move the plates directly. It only needs to act on the margins. Imagine a door held shut by enormous pressure but balanced on the edge of release. A child's push won't break it open, but if the door is already straining, even the lightest nudge might send it swinging wide. This metaphor drives much of the speculation around electromagnetic triggers. The crust, in this view, is not just physical rock, but also a vast electrical conductor. Stress accumulation may generate electric charges through piezoelectric minerals like quartz. These charges can create local fields, which in turn may interact with the ionosphere above. If a solar storm disturbs the ionosphere at just the right moment, it could synchronize with these local fields, nudging an unstable fault into rupture. It's a hypothesis with few controlled tests, but one that continues to attract interest whenever quakes and storms overlap in time. The Venezuelan sequence provided fodder for such interpretations. Two quakes, almost identical in strength, within 24 hours, occurring during one of the most geomagnetically active weeks of the year. The pattern was too precise for many to ignore. Some independent researchers quickly published preprints arguing that electromagnetic coupling might have played a role. They pointed to anomalies in satellite data which showed ionospheric irregularities over northern South America days before the quakes. Mainstream seismologists responded cautiously, noting that similar anomalies are often observed without any quakes following. Yet the coincidence of timing gave the arguments weight, at least in the court of public imagination. There is also the matter of earthquake lights. Though still poorly understood, These rare luminous displays, flickering glows, arcs, or flashes in the sky near seismic zones, have been documented before major tremors. Reports from Venezuela mention strange lights seen in the night sky, though many dismissed them as ordinary power line discharges. Still, the stories persisted. If true, they may have been the result of piezoelectric charges bursting from strained rocks, yet amplified under the disturbed ionosphere of a geomagnetic storm. For ordinary people, the technicalities mattered less than the feeling of connection. Watching auroras spread across northern skies while buildings shook to their foundations in Venezuela, the sense of a cosmic chain reaction was hard to shake. Was Earth merely caught in the crossfire of solar weather? Or was there a deeper rhythm at play, one that bound the sun's breath and Earth's heartbeat in a single pulse? Historical parallels add to the intrigue. The Great Chilean Earthquake of 1960, the largest in recorded history, coincided with notable solar activity. The 1989 Quebec blackout caused by a solar storm occurred just days before seismic unrest in nearby regions. None of these prove a causal link, but they feed the suspicion that electromagnetic Earth may be more sensitive to solar nudges than we admit. Scientists who entertain the idea caution against overreach. Correlation is not causation. Many quakes occur without solar storms, and many storms pass without quakes. But what if, in rare cases, the two overlap? What if certain fault systems, already teetering on the brink, are tipped by subtle electromagnetic interference? If so, it would mean that predicting quakes could someday involve monitoring not just ground stress, but also the sun itself. The notion of Earth as an electromagnetic body is not limited to seismic speculation. Our entire biosphere is tuned to rhythms of magnetism. Migrating birds navigate by geomagnetic cues. Whales may follow magnetic lines across oceans, and humans themselves exhibit subtle physiological responses to magnetic fluctuations. If life is sensitive to the electromagnetic Earth, why not the Earth itself? Perhaps quakes, like auroras, are part of a larger dialogue between sun, sky, and stone. In the aftermath of September's events, one thing was certain: the theory of electromagnetic earthquakes had found new fuel. Venezuela's twin tremors, arriving under the shadow of a solar storm and in the spotlight of an interstellar comet, felt too synchronized to ignore. Whether science ultimately validates the connection or consigns it to coincidence, the story captures the imagination. It reminds us that Earth is not an isolated rock, but part of a vast system of forces, invisible yet powerful, binding the ground we stand on to the stars we gaze at. The electromagnetic Earth, then, is both a scientific frontier and a metaphor. It is the idea that beneath the apparent randomness of quakes and storms lies a hidden order, a conversation written in fields of energy. Perhaps one day instruments will prove it beyond doubt. Until then, each time the ground shakes while the sky glows, we are left to wonder whether the universe just spoke in unison, if only for a moment, and whether we were paying close enough attention to hear it. Energy that doesn't add up. When astronomers first calculated the expected brightness of 3 Atlas, the math seemed straightforward. Like any comet, it's to be the product of sunlight striking gas and dust streaming off its surface. Its size and distance would define the limits of how luminous it could appear from Earth. Yet the data told a different story. Almost immediately, Atlas defied predictions, glowing far brighter than an object of its estimated mass and composition should. Each surge in its brightness curve left scientists scratching their heads, forced to admit an uncomfortable truth: the energy pouring out of Atlas simply didn't add up. Brightness in astronomy is not just aesthetics, it is energy made visible. For comets, it's usually the result of sublimating ice and dust scattering sunlight. Oumuamua, by contrast, was puzzling because it produced no visible coma, but still accelerated as if pushed by some hidden force. Atlas went the opposite direction. It displayed an enormous coma, glowing with a greenish hue, but the energy implied by its radiance didn't match the size or shape of the object's nucleus. If its brightness were truly proportional to outgassing, then Atlas would need to be shedding far more mass than observations could confirm. Instead, it seemed to radiate light with an intensity disproportionate to its physical constraints. The September solar storm only intensified the puzzle. As the coronal mass ejections swept past, the comet's brightness spiked dramatically. Flares of luminosity shot across the coma, captured by amateur and professional telescopes alike. This was expected to some degree. Solar particles often trigger outbursts in comets, but Atlas's surge was extreme. Its coma expanded so quickly that some estimates compared it to nearly half the sun's diameter, a staggering claim if accurate. Energy budgets didn't align. A body this size, with its estimated inventory of volatiles, shouldn't be able to sustain such output. Something was wrong with the math, or with the assumptions. Some researchers pointed to carbon dioxide. Unlike water ice, CO2 sublimates more vigorously when exposed to solar heating, and spectroscopic data suggested Atlas carried unusually pure reservoirs of it. This could explain some of the flare-ups, but not the scale. To produce the brightness actually measured, Atlas would need a surface tens of times more active than even the most volatile comets in history. And yet, there was no clear evidence of violent fragmentation or massive jets. Instead, the glow looked smooth, steady, almost controlled. This led to whispers of resonance, some unknown mechanism converting solar input into exaggerated emission. Could Atlas's dust grains scatter light more efficiently than usual? Polarimetry suggested something strange. Unusually large grains aligned in ways that produced peculiar reflections. It was as if the coma were structured, not random, bending light in ways we don't fully understand. If true, it might account for some of the excess brightness. But it raised another question. Why would an interstellar object born around another star carry such exotic dust? Was it chemistry? Was it origin? Or was it something else entirely? Then there was the anti-tail. This curious feature, pointing sunward rather than trailing behind, defied the normal dynamics of solar radiation pressure. Some explained it as a perspective effect, others as larger particles lagging differently than smaller dust. Yet when combined with the energy imbalance, the anti-tail seemed less like a quirk and more like a signature. It suggested forces acting on Atlas that were not acting on ordinary comets, or at least not in ways we typically measure. The inconsistency of brightness added further weight. Atlas didn't simply brighten in a smooth curve toward perihelion. Instead, it flared in pulses, then dimmed slightly, then surged again. These cycles made it look less like a passive body and more like a system, something with internal processes, something that responded to external nudges. Observers compared it to a beacon flickering on and off, though no one dared commit such comparisons to formal publications. Still, in astronomy forums and late-night observatory discussions, the unease was palpable. The energy surplus carried echoes of Oumuamua's mystery. That earlier interstellar visitor accelerated as though pushed by a rocket-like thrust, but with no visible outgassing. Harvard astronomer Avi Loeb had stirred controversy by suggesting it might be an alien probe thin as a sail, quenching sunlight like a sheet. Atlas, in contrast, gave the impression of too much energy, too much light for its mass. Where Oumuamua was too dim and too fast, Atlas was too bright and too consistent. Together, the pair framed a disturbing picture. Interstellar visitors may not obey the same physics we expect. Mainstream explanations proliferated nonetheless. Some argued that observational errors inflated Atlas's brightness measurements, though cross-checks between telescopes made this unlikely. Others suggested hidden fragmentation. Perhaps Atlas was breaking apart in ways invisible from Earth, exposing fresh surfaces that vented gas in bursts. But again, no clear debris trail was found. A few invoked exotic chemistry, organic compounds fluorescing under solar radiation, releasing light more efficiently than ordinary dust. It was plausible, but without precedent. Beyond the science, the public latched onto the symbolism. Here was a green star-like wanderer glowing in defiance of expectations, its brightness surging in the same days earthquakes shook Venezuela. Online forums and news outlets called it a cosmic omen, a signal in the sky. Ancient prophecies about emerald stars and heavenly torches resurfaced in circulation, fueling speculation that Atlas was more than just rock and ice. Whether coincidence or connection, the mismatch of energy gave the narrative weight. Something was happening that didn't fit the textbook. Even within cautious scientific circles, some began to consider fringe theories. Could Atlas contain radioactive elements emitting heat and light from within? Could it be a fragment of a larger body, a planet's core or crust ripped from another system, carrying exotic minerals that fluoresce differently? Could it even, some whispered, be artificial, a relic of technology, not geology? These ideas were not published in journals, but they circulated in the same way Umama had sparked whispers of alien design. Whatever the explanation, the numbers refused to balance. Observatories from Hawaii to Chile, from Europe to South Africa, all confirmed the same. Atlas was brighter than it had any right to be. Its coma radiated more energy than could be reasonably explained by sublimation alone. Each attempt to force the data into existing models left gaps, contradictions, or the need for unlikely assumptions. Something fundamental was missing. In science, anomalies are both curse and gift. They mock our theories, but also point the way to new ones. Atlas may prove, years from now, to be a chemical oddity, a comet that simply carried unusual ices. Or it may open doors into new physics, new understandings of interstellar matter. For now, though, it lingers as a riddle, a body that shines like a beacon, but whose power source remains concealed. And so astronomers keep watching. Each night, new data is logged. Each day, new debates unfold. The glow of Atlas continues, defying models, hinting at hidden reserves of energy or hidden structures that scatter sunlight with uncanny efficiency. Whatever the case, it has forced us to confront a humbling truth. Sometimes the universe writes equations we cannot yet solve. The energy of Atlas doesn't add up, and until it does, the questions will burn brighter than the comet itself. Echoes of Oumuamua. When 3I Atlas burst onto the scene, many astronomers couldn't help but feel a familiar chill. The last time the solar system played host to such an enigmatic visitor, in 2017, the world was introduced to a cigar-shaped object called Oumuamua. That first interstellar guest had left behind more questions than answers. No coma, no dust, no clear explanation for its acceleration, and a shape so unusual that scientists struggled to describe it. Years later, debates still rage about whether Oumuamua was a natural fragment of rock and ice, or something far more engineered. So when Atlas began to misbehave in its own way, glowing with energy that didn't fit the models, the echoes of Oumuamua reverberated instantly. It was as though the cosmos had delivered a sequel, not by accident, but by design. Oumuamua had arrived silently, discovered only after it had already passed closest to the sun and was hurtling away. Astronomers had precious little time to study it, and the lack of data left a vacuum that speculation quickly filled. Some argued it was a sliver of nitrogen ice chipped off a distant exoplanet. Others said it was a cosmic dust pancake, while a vocal minority suggested it might be artificial, an abandoned probe or fragment of alien technology. What united all camps was frustration. Oumuamua defied every tidy category we tried to place it in. It was neither fully asteroid nor comet. It broke rules but refused to show its hand. Atlas, by contrast, arrived with a glow so obvious it was impossible to ignore. Yet the nature of its anomalies carried a haunting familiarity. Just as Oumuamua's acceleration couldn't be explained by outgassing, Atlas's luminosity refused to obey standard energy budgets. Both objects, in different ways, appeared to cheat physics. Both carried signatures that made them look less like passive lumps of matter and more like systems responding to unseen triggers. For scientists who had lived through the Oumuamua debates, Atlas was déjà vu on a grander scale. The echoes went beyond scientific puzzles. They extended into timing. Oumuamua appeared at a moment when interest in exoplanets was skyrocketing, when humanity was just beginning to realize how many Earth-like worlds dotted our galaxy. It was almost symbolic, arriving as if to remind us that the cosmos was not a static backdrop, but an active stage. Atlas, too, entered the scene at a moment of heightened global unease. Earthquakes, solar storms, novas lighting up the sky. Once again, an interstellar visitor seemed tied, whether by coincidence or something deeper, to moments of upheaval and pattern. The comparison also revived uncomfortable questions. Why have the only 3 interstellar visitors we know of, Oumuamua, Borisov, and Atlas, each behaved in ways that set them apart from ordinary solar system bodies? Borisov was the most normal of the trio, looking like a hyperactive comet. But Oumuamua and Atlas are bookends of anomaly, one too dim and too fast, the other too bright and too stable. Could this be simple statistical fluke? Or are we glimpsing a category of interstellar objects that carry properties we've never encountered before? If so, why do they appear in moments that already feel cosmically charged? Avi Loeb, the Harvard astronomer who championed the alien probe hypothesis for Oumuamua, was quick to comment on Atlas. Though more cautious this time, he noted the parallels in public interviews. When something doesn't fit existing models, we must resist the temptation to dismiss it. Oumuamua taught us that the universe still holds surprises. Atlas may be another such lesson. His words carried the same undertone of defiance that made him both respected and controversial. To many, Atlas was proving that Oumuamua was not an outlier, but part of a larger mystery still unfolding. The very shape of Atlas's story echoed Oumuamua's. Both confounded predictions of how interstellar bodies should behave, both forced revisions to models, both fueled waves of public speculation that blended science with myth, and both left us staring at the sky with the uncomfortable sense that we were being watched as much as we were watching. If Oumuamua had sparked whispers of probes and sails, Atlas fanned them with its beacon-like glow, flickering in ways that seemed less random than rhythmic. There was another echo, subtler but no less disturbing, the refusal of mainstream science to fully engage with the strangeness. With Oumuamua, many papers downplayed its anomalies, straining to fit it into cometary categories despite the absence of a coma. With Atlas, similar rhetorical gymnastics appeared. Reports emphasized its comet-like nature while glossing over the glaring mismatch in energy. The pattern was clear. Science prefers discomfort to upheaval. Better to patch models with improbable assumptions than to admit we may not understand what we are seeing. And yet the echoes persist, rattling louder each time. For the public, the pairing of Oumuamua and Atlas became irresistible. Social media dubbed them the twins, emissaries from beyond, perhaps even linked fragments of a larger body or remnants of some shattered artifact. Artistic renderings circulated, depicting Oumuamua's elongated shard, alongside Atlas's glowing emerald coma, like yin and yang, opposites mirroring each other. The story resonated not because it was proven, but because it fit a deeper instinct. The sense that we are participants in a drama larger than ourselves, one written in patterns across the stars. Even in hard science, the echoes are practical. Both objects underscore how unprepared we are to study interstellar visitors. We lack dedicated intercept missions, we lack long-range warning systems, and we lack the flexibility to pivot quickly when a mystery arrives at our doorstep. Oumuamua slipped away before we could grasp it. Atlas, brighter and longer lasting, gives us more time, but still no spacecraft capable of reaching it. In this sense, the echoes serve as warnings. We are not ready, and the universe is not waiting for us to be. Speculation, of course, spirals outward. Could Oumuamua and Atlas belong to the same population dispatched from a single system long ago? Could they be debris from ancient galactic engineering, drifting relics of civilizations long gone? Or are they natural fragments, teaching us that interstellar chemistry and physics produce results stranger than anything we've modeled? Each theory carries its own allure, but all point to the same conclusion. Oumuamua was not alone. What unsettles many is the rhythm. One interstellar anomaly might be dismissed as fluke. Two, so different yet equally confounding, begin to suggest a pattern. Patterns invite speculation, and speculation fuels mystery. As humanity peers deeper into the cosmos, the echoes of Oumuamua ring louder through Atlas, telling us that our place in the universe is not as solitary as we once imagined. In the end, the story of Atlas cannot be told without the ghost of Oumuamua. The two are bound by mystery, by anomaly, and by timing. Oumuamua left us with a question mark. Atlas has returned with an exclamation point. Together they form a dialogue, one that stretches across years and across light years, a conversation between our solar system and the unknown. And until we learn to listen properly, by preparing missions, by admitting strangeness, by opening our minds, the echoes will continue. Echoes that sound less like coincidence and more like the first notes of a pattern waiting to be revealed. The human side of the quakes. When the first Venezuelan quake struck, it was not the shaking of buildings or the cracking of highways that defined the experience. It was the sound. Survivors described it as a deep growl rising from the earth, a guttural resonance that seemed to rattle not just walls but the bones within their bodies. In Caracas, office towers swayed in slow, sickening arcs, while apartment residents clutched door frames and prayed aloud. In coastal towns, fishermen abandoned their boats, sprinting inland as the ground heaved beneath them. A 6.1 magnitude tremor may not rank among the deadliest quakes in history, but to those who lived through it, the terror was unforgettable. The human story of the Venezuelan twin quakes is one of raw emotion, panic, disbelief, resilience, and exhaustion. When the first tremor passed and no catastrophic collapse followed, relief washed over communities. People gathered in plazas, trading nervous laughter with shaky voices. They called loved ones, checked on neighbors, and shared the universal human instinct to ensure no one was alone in the aftermath. Power flickered in some regions, water lines cracked, and traffic snarled as drivers abandoned vehicles mid-road. Yet there was comfort in believing the worst was over. Then came the second strike. Barely a day later, as families were sweeping broken glass from their kitchens and returning to school or work, the Earth convulsed again, this time at 6.3. The repetition was devastating, not because of physical destruction alone, but because it shattered the fragile sense of recovery. Psychologists call this disaster fatigue, the moment when hope of safety collapses under the weight of repetition. Residents spoke of a cruel déjà vu, the same sound, the same terrifying sway, the same sprint into the streets. Except this time it felt worse, because it robbed them of the nightmare belief that the nightmare was over. For children, the trauma was acute. In classrooms, students screamed and clutched each other as desks rattled across the floor. Many refused to return indoors for days afterward, insisting on sleeping outside with parents. Elderly residents, many with memories of past disasters like the 1997 Cariaco earthquake, were reminded of the fragility of life in a seismic nation. "We thought we had seen the worst," one grandmother told reporters, "but when it came again, I felt my heart break." Social media became both lifeline and amplifier. Videos of chandeliers swaying, supermarket shelves collapsing, and terrified families huddling together went viral, shared with captions like, "Again," and "Twice in one day." Global audiences, already fascinated by the strange timing of cosmic events, absorbed these clips alongside headlines about 3I Atlas and the solar storm. For Venezuelans, however, the experience was far more immediate. The constant aftershocks that rattled through the night, the sirens wailing in the distance, the volunteers digging through debris in coastal towns where walls had collapsed. The economic toll compounded the human stress. Venezuela, already grappling with shortages of basic supplies, suddenly faced new burdens: cracked roads blocking transport, damaged pipelines disrupting utilities, and businesses shuttered as inspections dragged on. Relief agencies scrambled to provide tents and food, while hospitals filled with patients suffering from injuries, shock, or stress-induced conditions. Nurses reported spikes in hypertension, fainting, and heart attacks, triggered not by direct injuries, but by the fear itself. For many families, the quakes were not just physical assaults, but psychological ones, leaving scars less visible but just as lasting. Religious communities rallied almost immediately. Churches filled within hours of the second quake, echoing with prayers, hymns, and whispered pleas. Pastors framed the twin shocks as tests of faith, while some congregants whispered darker interpretations: signs, omens, punishments, or warnings. In a culture where the boundary between natural disaster and spiritual meaning is thin, the quakes became more than geological events, they became existential ones. And when the glowing green coma of Atlas appeared in headlines the same week, the human mind naturally wove connections. Sky and ground, heaven and earth, both seemed to tremble together. Amid the fear, acts of resilience shone. Neighbors formed bucket brigades to clear rubble from streets. Families shared food and blankets with strangers sleeping outdoors. Teachers calmed children by turning aftershocks into counting games, helping little ones manage fear by treating tremors as numbers to log rather than threats to dread. In one coastal town, musicians gathered in a plaza the night after the second quake, strumming guitars and singing folk songs under the open sky. It was defiance through harmony. If the earth could roar, so could human voices. Yet trauma lingered. Psychologists warned that the twin quakes would leave deep psychological impacts, particularly because of their uncanny timing. Survivors of single quakes often heal once stability returns, but when two arrive in such rapid succession, the sense of unpredictability magnifies. People stop trusting the ground beneath them, one Caracas therapist explained. They live with the belief that it could happen again at any second, and that belief never fully goes away. Children developed sleep disturbances, nightmares of walls collapsing or the sky glowing green. Adults, especially those already struggling with economic uncertainty, sank into anxiety and hypervigilance. The Venezuelan quakes became a national symbol of fragility, but also of endurance. News anchors spoke of 2 blows in one day and compared the nation's resilience to standing after being knocked twice by the same opponent. In political circles, the tremors became metaphors for the country's struggles. Some argued that just as Venezuela survived the quakes, it could survive its political and economic crises. Others cynically claimed the disasters highlighted government failures in infrastructure and emergency preparedness. But for ordinary citizens, the quakes were not metaphors. They were nights of terror, mornings of rubble, and weeks of waiting for normalcy to return. It is easy from afar to reduce these quakes to data points: magnitude 6.1, magnitude 6.3, depth kilometers, energy release in joules. But energy on paper cannot capture the shaking hands of a mother trying to calm her child, or the pounding heart of an elderly man clutching a rosary as the ceiling sways above him. Numbers do not tell of the silence that falls right after the shaking stops, when everyone waits, breath held, wondering if it is truly over. Nor do they capture the eerie laughter of neighbors relieved to find themselves still alive, joking nervously to mask the shared terror. The human side of the Venezuelan quakes is also the story of perception. For scientists, 2 tremors within 24 hours is rare but explainable. For the public, the symmetry felt deliberate, almost scripted. Coupled with the flare of Atlas and the storm of the sun, the experience became a tapestry of coincidences woven into meaning. Humans are pattern seekers. We cannot help but ask, why now, why here, why both at once? And when answers are not forthcoming, we tell stories. In Venezuela, those stories ranged from divine tests to cosmic alignments, from ancient prophecies to whispered fears of the world unraveling. But the most important story was lived in the streets. Neighbors helping neighbors, children clutching parents, communities relearning that survival is collective. In the end, the human side of the quakes was not about fear alone, but about connection. 2 strikes in one region in one day left behind scars, but also memories of solidarity. And perhaps that is the final echo. While the earth cracked, humanity held together, and in that fragile unity, under the trembling ground and the flickering green glow of a comet in the sky, Venezuelans became living witnesses to a moment when cosmic timing and human survival seemed bound by the same thread. The pattern hunters. In the wake of September's uncanny convergence, 2 Venezuelan earthquakes in 24 hours, a solar storm sideswiping Earth, and the eerie green glow of 3A Atlas brightening against the night sky, people did what they have always done. They searched for meaning in the chaos. Scientists called it coincidence. Statisticians pointed to probabilities, however small. But beyond the numbers and technical jargon, ordinary human minds instinctively reached for patterns. The pattern hunters, those who sift through history, myth, and science alike for hidden connections, saw something larger taking shape. The human brain is wired for this. Evolutionarily, our ancestors survived by detecting patterns in rustling grass, flickering shadows, or the cycles of the heavens. Seeing order and noise gave us an edge, even if sometimes the pattern wasn't real. Better to mistake the wind for a predator than to miss the predator in the wind. This instinct persists, and in moments when earth and sky seem to move in eerie synchrony, it surges with full force. The Venezuelan quakes provided fertile ground. To the pattern hunters, it wasn't just that 2 quakes struck in such quick succession. It was that they struck while the sun was erupting and an interstellar object was misbehaving. A trifecta of cosmic and terrestrial events that, to them, looked more like choreography than chance. Was it possible, they asked, that the timing revealed some hidden connection? Could the Earth, the Sun, and the interstellar wanderer be linked by forces science has yet to map? Pattern hunting has deep cultural roots. Ancient civilizations saw eclipses and comets as portents, linking them to floods, famines, or the rise and fall of empires. The Chinese meticulously recorded guest stars that flared in the heavens, later recognized as novas and supernovas. Medieval chroniclers wrote of fiery signs in the sky before plagues or wars. The Aztecs viewed earthquakes as part of a cosmic cycle, a reminder that worlds were born and destroyed in rhythm with celestial forces. Across millennia, pattern hunting has been less superstition than survival strategy, a way of weaving meaning into the terrifying unpredictability of nature. September 2025 was no exception. Online forums lit up with timelines carefully pieced together. Solar storm on the 21st, first quake on the 24th, second quake on the 25th, Atlas flare recorded across observatories, nova reports from 2 constellations, auroras visible unusually far south. The alignment looked uncanny when condensed into a single chart. Posts went viral under captions like "Too much for coincidence" and "September's cosmic script." Amateur sleuths drew diagrams connecting Earth's magnetic field to the solar wind, then linking seismic activity to geomagnetic fluctuations, then drawing a final line to Atlas's glow. Mainstream scientists bristled. "Correlation is not causation," they repeated. "Earthquakes occur all the time, solar storms occur all the time, comets flare unpredictably all the time. The odds of overlap are not zero," but their words, however logical, rang hollow against the visceral sense of synchronicity. People didn't just see coincidences, they felt them. When the ground shook and the skies flared in the same week, it felt like rhythm, not noise. Pattern hunters thrive on anomalies, and Atlas provided them in abundance. Its green hue, its anti-tail, its oversized coma, and its energy surplus all defied tidy explanation. Oumuamua had carried its own signature of strangeness years earlier. Now Atlas seemed to echo it, as though interstellar visitors always arrive, wrapped in mystery. The fact that Venezuela's quakes occurred in the very window when Atlas's flare was most pronounced only deepened the intrigue. "It's almost like it wanted to be noticed," wrote one commentator, echoing the language once used about Oumuamua. This wasn't confined to internet forums. Even scientists, though careful with their words, acknowledged the odd timing. Papers published in preprint servers noted ionospheric disturbances over South America before the quakes, hinting at links between solar storms and seismic events. Others speculated that electromagnetic coupling between the ionosphere and stressed crust could play a role. Though far from consensus, these discussions gave pattern hunters fuel. If even some scientists entertained the possibility, perhaps their intuition wasn't so wild. Psychology helps explain why patterns matter so deeply. Humans crave narrative. Randomness unnerves us because it strips away meaning. But when events line up, quakes, storms, comets, the temptation is irresistible to string them together like beads on a thread. Narrative transforms chaos into story, and story gives us power, even if only the illusion of understanding. September's events became such a story. The sun lashes out, Earth trembles in reply, and a cosmic visitor illuminates the skies as witness or messenger. It was a narrative too cinematic to ignore. For Venezuelans living through the quakes, the pattern hunting took on cultural tones. Some turned to religion, framing the events as divine warnings. Others recalled indigenous stories of earth-shaking stars and green fires in the sky. In oral traditions, comets and quakes often intertwine, symbols of cosmic imbalance mirrored in earthly upheaval. To those familiar with such lore, Atlas's green glow during the twin quakes felt like a page from an old prophecy written anew. The echoes reached further back still. In 1755, the Lisbon earthquake devastated Portugal on the same day as a solar eclipse, sparking centuries of theological and scientific debate. In 1908, the Tunguska event in Siberia flattened forests after reports of a fireball streaking across the sky. Each time, humans linked heaven and earth in patterns, sometimes rightly, sometimes wrongly. But always the search itself testified to our hunger for coherence. September 2025 joined that lineage of moments when the world seemed to hum with hidden order. Not all pattern hunters are mystics. Some approach with scientific rigor, compiling data sets, analyzing correlations, and probing anomalies with algorithms. Yet even in these efforts, there is often a sense of chasing something elusive, as though the patterns hover just beyond reach. One such researcher compared Atlas's brightness fluctuations with global seismic data, claiming to find temporal overlaps beyond statistical chance. Another plotted geomagnetic indices against earthquake occurrences, suggesting subtle but real connections. While peer review has yet to confirm such claims, their existence underscores the persistence of the hunt. And perhaps that persistence is the real story. The pattern hunters, whether ancient shamans reading stars or modern scientists parsing satellite feeds, remind us of our place in the cosmos. We are meaning makers in a universe that resists easy meaning. We are driven to connect dots, to sketch constellations in random scatter, to weave story out of noise. Sometimes the patterns are illusions. but sometimes they reveal truths we were blind to before. Atlas and Venezuela's quakes may yet prove coincidental. The sun may erupt again without any ground trembling in reply. Earth may quake again without a comet glowing overhead. But the fact that these events converged in September forced us to look more closely, to question more deeply, and to admit the possibility that the world is more interconnected than we realize. The pattern hunters may be dismissed as dreamers, but they are also pioneers. They remind us that every great discovery, from the cycles of eclipses to the orbits of planets, began as a pattern glimpsed where others saw chaos. And so the question lingers: when Earth shakes and skies glow in tandem, are we merely fooled by coincidence, or are we standing at the threshold of a larger truth? The pattern hunters don't claim certainty, they claim curiosity. And in that restless curiosity, they carry forward humanity's oldest tradition, the refusal to accept randomness when the universe whispers of rhythm. In September 2025, the whispers were loud enough for all to hear. Whether science will confirm the patterns or dismiss them, the fact remains: millions of people saw order in the chaos. And once seen, patterns are not easily unseen. They echo in memory, shaping the way we look at the next quake, the next comet, the next solar storm. And perhaps one day they will guide us to the realization that the universe is speaking, not in accidents, but in patterns we are only just beginning to understand. Global eyes on September eyes. From the moment the first quake rippled through Venezuela on September 24th, the world's gaze began to sharpen. By the time the second struck barely a day later, with news feeds already humming with reports of a solar storm and the inexplicable brightening of 3i Atlas, September had become more than a month. It had become a stage. Events that might normally be viewed in isolation suddenly collapsed into one narrative. Around the globe, scientists, journalists, and ordinary people found themselves staring at the same question: what was happening in September, and why did it feel like so much was unfolding at once? The scientific community responded first with careful curiosity. Astronomers monitoring Atlas were already working overtime, logging its erratic light curve and attempting to pin down the reasons for its outsized glow. Geophysicists pored over seismograph data from Venezuela, noting the unusual symmetry of two quakes in 24 hours. Space weather experts published real-time updates on the solar storm's path, its interaction with Earth's magnetosphere, and its likely effect on satellites. Each field operated in its own domain, but the timing forced overlap. Panels were convened, joint conferences called, and late-night discussions between researchers carried a tone not of routine, but of urgency. The month felt uncanny, and even scientists not prone to exaggeration admitted it was unusual to see so many rare events compressed together. Meanwhile, media outlets across continents competed to frame the story. European newspapers ran features with headlines like "September's Cosmic Storm, Coincidence or Connection?" In Asia, commentators drew comparisons to historic sky omens recorded before great dynastic shifts. North American channels leaned into cinematic phrasing: a green comet, a raging sun, and the Earth itself shaking. What are the odds? In Latin America, the tone was more personal. Venezuelan outlets balanced the grim local aftermath with the surreal sense that their national trauma was being tied to a cosmic narrative far beyond their borders. For many Venezuelans, this global attention felt both unsettling and strangely validating. The world was watching not just their suffering, but the strange convergence of sky and ground that framed it. The internet became a hive of speculation. Timelines were shared, mapping the nova explosions in distant constellations alongside the solar flare, the comet flare, and the Venezuelan quakes. Amateur sleuths labeled it the September Chain, with graphics depicting Earth at the center of crisscrossing arrows from sun, comet, and quake. Viral posts compared the cluster to past months of global upheaval: March 2011 with Japan's quake and tsunami, August 1883 with Krakatoa's eruption, or even November 1755, when Lisbon's Great Quake coincided with celestial portents. Each comparison suggested that September 2025 was not just another month, but one that belonged to the history of cosmic striking Earth narratives. Governments, too, took notice. Space agencies released cautious statements acknowledging Atlas's anomalies, while downplaying doomsday speculation. The European Space Agency emphasized that no evidence links interstellar objects to seismic activity, while NASA highlighted the rarity of observing such a bright interstellar visitor. Yet between the lines of reassurance, the mere act of comment revealed something. September's events had grown too large to ignore. Even agencies that typically steer clear of speculation felt compelled to acknowledge the strange simultaneity. In some cultures, September was framed through prophecy. In parts of the Middle East, sermons invoked ancient texts describing green stars or twice-shaken ground. In Asia, astrologers linked the events to alignments of planets and the year's fiery energies. In South America, folklore of earth-shaking deities resurfaced, reinterpreted through the lens of a sky lit by an emerald visitor. The global eye was not uniform. Science, religion, folklore, and social media each shaped the lens differently, but the shared sense of awe was unmistakable. The visual spectacle helped. Auroras danced across skies far outside their usual haunts, captured in photographs from Scotland, Germany, and the northern US. These images, glowing with green and purple light, looked eerily similar to telescope shots of Atlas's coma. Journalists juxtaposed them in spreads, asking whether Earth itself was echoing the comet's glow. For millions who had never heard of interstellar objects, Atlas became a household name overnight. It was no longer just a scientific designation, it was a character in September's drama, cast alongside the sun and Earth itself. What made September feel even more unusual was the sheer variety of rare events compressed together. It wasn't just quakes or storms or comets, it was all of them at once. Add to this the nova reports, visible briefly to the naked eye in 2 constellations. And the month began to look less like coincidence and more like a script. Pattern hunters mapped it, skeptics mocked it, but the global eye couldn't look away. Something about September demanded attention. Psychologists observed the collective response with interest. They noted how quickly people around the world framed events as connected, how narratives of cosmic timing spread faster than scientific disclaimers. It's not irrational, one researcher explained. When multiple rare events cluster together, our brains naturally search for coherence. Storytelling is our survival tool. September 25, they argued, became less about data points and more about a global myth in the making, where billions shared the same anxious fascination. The global eye also turned practical. Seismologists debated whether Venezuela's twin quakes could serve as a model for predicting paired seismic events elsewhere. Space weather agencies issued calls for more resilient infrastructure, warning that the September storm, while moderate, hinted at the scale of disruptions to come as Solar Cycle 25 reached its peak. Astronomers pushed for accelerated funding of missions capable of intercepting interstellar visitors, citing Atlas as a missed opportunity for direct study. In this way, the strangeness of the month translated into policy debates where awe became argument. At the same time, conspiracy theories flourished. Online forums suggested that governments were hiding data about Atlas, that the quakes were artificially triggered, or that ancient prophecies were being fulfilled. While fringe, these theories spread widely, fueled by the very real fact that mainstream explanations felt incomplete. The human hunger for pattern, amplified by mistrust of authority, produced narratives as elaborate as any ancient myth. In these stories, September was not coincidence but revelation, whether of hidden technology, cosmic cycles, or divine will. For scientists, the challenge was balancing caution with honesty. Many privately admitted that Atlas's energy output did not add up, that the Venezuelan double quake was unusual, that the timing was uncanny. But publicly, the emphasis remained on caution, lest speculation spiral into panic. Yet in their very restraint, they fueled the sense that something larger was being withheld. Silence can amplify mystery as much as words. From a distance, September now looks like a case study in synchronicity. Earth, sun, and sky all seem to move in rhythm, and billions of people around the globe watch together. Whether coincidence or connection, the global eye transformed it from isolated events into a narrative of cosmic timing. For some, it was a warning. For others, a spectacle. For all, it was unforgettable. In the end, the phrase that echoed most often was simple: too much for coincidence. Whether whispered in Caracas, tweeted in New York, preached in churches, or muttered in observatories, those words captured the essence of September 2025. The world saw a pattern, and once seen, it could not be unseen. The global eye had turned, and in its gaze, the month became myth. What that myth means, whether it is omen, accident, or hint of a deeper connection, remains open. But September proved something undeniable. In a world often fragmented, sometimes it takes the trembling of the earth and the glowing of the skies to unite our attention. For one strange month, billions looked up, looked down, and felt the same uneasy question rise in their minds. Are we witnessing coincidence or the choreography of something far greater? The anti-tail phenomenon. Among all the peculiarities surrounding 3I Atlas, its green glow, its oversized coma, its erratic flares, the most visually striking was the sudden appearance of its anti-tail. To the casual observer, the word itself sounds contradictory. How can a comet have a tail that points toward the sun instead of away from it? Yet that is exactly what astronomers reported in September. A thin, luminous spike extending sunward, defying the rules most students of astronomy learn in their first lessons. The anti-tail phenomenon is rare but not unheard of. Still, in the case of Atlas, its presence carried an aura of unease, because it emerged at the very moment the world was already straining under earthquakes, solar storms, and nova explosions. It felt less like an oddity of perspective and more like a signature, a message written in the sky in emerald light. Normally, a comet's tail forms when solar radiation and the solar winds strike volatile ices, sublimating them into gas and dust that stream away from the nucleus. Radiation pressure drives the dust outward, while charged particles shape the ion tail. Both tails should always extend away from the sun, creating that iconic comet streak, stretching into the dark. But sometimes, under specific orbital alignments, the geometry creates an illusion. Large dust particles, moving more slowly than lighter grains, remain along the comet's orbital path. From Earth's perspective, this lingering debris can look like a tail pointing toward the sun. That is the basic textbook explanation for an anti-tail. But with Atlas, the story was more complicated. For one, the anti-tail appeared unusually sharp and luminous. Photographs from observatories showed a blade-like spike extending sunward, brighter and better defined than models predicted. This wasn't a faint optical trick. It was a feature so conspicuous that even amateur astronomers noted it immediately. More troublingly, the anti-tail seemed to persist longer than expected. Typically, such illusions are fleeting, visible only for a narrow window of alignment. Yet Atlas's anti-tail lingered, pulsing with brightness as the comet flared in the aftermath of the September solar storm. Speculation spread quickly. Some researchers suggested Atlas's dust grains were unusually large or cohesive, resisting dispersal in ways typical cometary dust does not. Others proposed electromagnetic interactions between the comet's charged particles and the solar wind might have enhanced the structure, creating a false stability. Still others admitted uncertainty. We don't fully understand why this anti-tail looks so defined, one European astronomer conceded. In science, words like don't fully understand carry more weight than they seem. They signal gaps, and gaps invite imagination. The public, already captivated by Atlas's green glow, seized on the anti-tail as further proof of strangeness. Online headlines blared, "Alien comet defies physics," and "Visitor points back at the sun." Social media lit up with interpretations. Some saw it as a cosmic arrow pointing back to the source of life. Others spun myths of swords in the sky, with the anti-tail as a blade poised against the sun itself. In Venezuela, where survivors were still reeling from the double quake, some communities whispered that the anti-tail was a sign that heaven was drawing a line between earth and sky, warning of imbalance. Scientists worked to temper these interpretations, publishing explanations of anti-tails as optical illusions. Diagrams circulated showing how dust trails align with Earth's vantage point. But the timing undercut their reassurance. Why should Atlas's anti-tail appear during the very week when a solar storm surged, quakes struck, and novas flared? Why should it persist longer than usual? The geometry explained the basics, yes, but the scale and timing remained suspiciously uncanny. The anti-tail also raised deeper questions about Atlas's dust. Polarimetry readings hinted at unusual grain structures, larger, denser, perhaps even metallic in composition. If true, these grains would not scatter or disperse like ordinary comet dust, making the anti-tail appear sharper. But why would an interstellar comet carry such anomalous material? Was it forged in an environment unlike our solar system, or did it undergo processes alien to our models? The anti-tail in this light became more than a curiosity. It became evidence of difference, a fingerprint of Atlas's otherworldly origin. Echoes of Oumuamua returned here too. That earlier interstellar visitor had produced no visible tail at all, baffling scientists who expected outgassing. Atlas, by contrast, flaunted not only a massive coma, but a tail pointing in the wrong direction. Taken together, they painted a picture of interstellar objects as rebels, breaking rules, flipping expectations, behaving in ways that make terrestrial science look provincial. It was as if each visitor carried a reminder. The universe is larger, stranger, and less obedient than we believe. Some fringe voices suggested the anti-tail was not dust at all, but something artificial, structures or emissions directed sunward for unknown purposes. While mainstream science dismissed such ideas, they spread nonetheless, fueled by the eerie appearance of the feature. It doesn't look like dust, one amateur insisted online, posting processed images that exaggerated the tail's blade-like shape. It looks like a beam. To those already convinced that Oumuamua hinted at technology, Atlas's anti-tail became the next breadcrumb, a cosmic signature written for those willing to look beyond conventional explanations. For the pattern hunters, the symbolism was irresistible. An interstellar object points back toward the sun just as the sun erupts in a storm, and Earth trembles in sympathy. Three forces, comet, star, and planet, aligned in a choreography too symmetrical to dismiss. Ancient traditions often saw comets as swords, omens of battle or judgment. The anti-tail revived that imagery with unsettling vividness. The sword was not pointed at Earth, but at the sun itself, as if reminding humanity where the true source of power and danger resides. Meanwhile, telescopes continued tracking the anomaly, logging data that defied neat categorization. The anti-tail did not dissipate as quickly as predicted. Instead, it appeared to fluctuate in intensity, sometimes brighter than the main dust tail itself. At moments, it seemed almost to pulse, fading and reappearing with a rhythm no one could yet explain. If this was mere dust geometry, it was unusually stubborn, refusing to behave as models dictated. In hindsight, the anti-tail became one of the defining images of Atlas. Even as its green glow dominated headlines, the photographs of its sunward spike captured imaginations worldwide. Astronomers debated the technicalities, but the public remembered the picture. A comet with a tail that refused to follow the rules. That image fed both awe and unease, a symbol of how even the most established scientific laws can bend under the pressure of the unknown. And so, the anti-tail phenomenon became more than a curiosity. It became a metaphor for September itself. Just as the tail pointed in the wrong direction, so too did the month defy expectations. Earthquakes struck twice where once would suffice. A solar storm arrived in sync with terrestrial upheaval. A comet glowed brighter than its mass allowed. Everywhere the arrows pointed against the grain, against the predictions, against the neat narratives of science. The anti-tail was September in miniature, a reversal, a defiance, a reminder that the universe does not owe us consistency. For some, that was terrifying. For others, exhilarating. But for all, it was unforgettable. When future generations look back at 3 Atlas, they will see not only the numbers and data tables, but the images, the emerald glow, the oversized coma, and the sword of light pointed at the sun. They will ask what it meant, and whether it was only illusion or something more. And perhaps they will conclude, as many did in September, that the anti-tail was not simply dust, but a symbol of mystery, of reversal, of the unsettling truth that sometimes the universe looks back at us, pointing directly at the questions we would rather not ask. Coincidence versus correlation. When the dust of September's events settled, 2 Venezuelan earthquakes in 24 hours, a solar storm brushing past Earth, novas flaring in the night sky, and the interstellar wanderer 3I Atlas glowing brighter than predictions allowed, the debate crystallized into one central question. Was it all coincidence, or was there correlation? Scientists, statisticians, journalists, and ordinary people wrestled with the same dilemma, each arriving at different answers depending on what they valued more: numbers or narrative, probability or perception. The case for coincidence is, at first glance, overwhelming. Earthquakes happen daily, solar storms are part of the sun's natural cycle, novas appear every year, though rarely bright enough to be noticed without telescopes, and comets flare unpredictably, driven by volatile ices and dust. Statistically, The chance that some of these events would overlap is not zero. In a world of constant activity, tectonic, solar, stellar, coincidences are inevitable. Skeptics argue that our brains exaggerate the rarity of timing, forgetting how much noise exists in the background. You don't notice the thousands of times events don't line up, one geophysicist explained. You only notice when they do. Yet the case for correlation has its allure. Timing, after all, is everything. The Venezuelan quakes were not ordinary tremors. They were unusually matched in strength and separated by barely a day. The solar storm did not occur in isolation. It coincided with Atlas's unexplained surge in brightness. The novas did not erupt months apart. They flared within days of the other anomalies. Correlation, some argued, might not mean direct causation, but it does suggest synchronicity. The universe, they whispered, seemed to hum with a rhythm, and September was the month when multiple instruments struck the same note. This tension between coincidence and correlation has a long history. In science, the gold standard is causation, a demonstrable mechanism linking one event to another. Without it, correlations are dismissed as noise. But outside science, in the realm of human experience, correlation is enough. Cultures have built entire cosmologies on perceived patterns: eclipses before famines, comets before wars, earthquakes before dynastic falls. Even when causation was lacking, the correlations felt undeniable. September's sequence revived that ancient impulse, reminding us that humans are pattern hunters by nature. Consider the Venezuelan quakes. Seismologists mapped them to a subduction zone where the South American and Caribbean plates grind relentlessly. No solar storm, no comet, no cosmic event was needed to explain them. Yet the fact that they struck during one of the most geomagnetically active weeks of the year invited speculation. Could electromagnetic disturbances in the ionosphere have nudged already unstable faults toward rupture? Could the solar storm, by altering Earth's magnetic environment, have added just enough noise to push the crust over the edge? The mechanisms are unproven, but the alignment was too precise for many to ignore. Then there was Atlas. Its light curve had been puzzling before September, but the solar storm's timing with its flare was uncanny. Astronomers offered explanations. Perhaps charged particles energized volatile gases in its coma, triggering the outburst. That would be correlation in the truest sense, a storm from the sun directly linked to the comet's glow. But why did the flare align so neatly with Earth's double quake? Was that coincidence piled atop correlation? Or was there a deeper thread tying them all together? The difficulty lies in disentangling layers of timing, deciding which alignments matter and which are happenstance. The novas added further fuel. In a typical year, one or two novas become bright enough to be detected by the naked eye, often by trained observers under dark skies. In September, two such stellar eruptions were reported in close succession, dazzling amateur astronomers. To the pattern hunters, this was not random. Stars exploded, the sun erupted, Earth quaked, and a comet from another star system lit the sky, all within the span of days. To skeptics, it was nothing more than the law of large numbers. Given enough events in the universe, some will always overlap, but to believers, it was correlation, a cosmic crescendo. Psychology plays a decisive role here. Humans are uncomfortable with randomness. We want meaning, causation, purpose. When events cluster, we perceive them as linked even when they are not. This tendency, called apophenia, is the same that makes us see faces in clouds or constellations in random star fields. Yet it has also led to genuine discoveries. Johannes Kepler saw correlations in planetary movements where others saw chaos, eventually unlocking the laws of orbital motion. Gregor Mendel saw patterns in pea plants where others saw chance, discovering genetics. The line between illusion and insight is thin, and sometimes the only way to tell is to chase the pattern until it yields either truth or dead ends. September tested that line. For some, the events were purely coincidental, a clustering of unrelated phenomena. For others, the clustering itself was meaningful. Even without causation, synchronicity can feel like a form of order. Carl Jung coined the term to describe meaningful coincidences that defy probability. September's anomalies fit the mold perfectly. Events separated by scale and mechanism, yet bound by timing in a way that felt significant. Was it just a trick of perception? Or was it the universe whispering in a language we have yet to learn? The debate spilled into the public sphere. News programs invited experts to explain probabilities, while audiences latched onto the drama. One commentator calculated the odds of quakes, solar storms, novas, and comet flares overlapping within the same week as astronomically low. Another countered that because the universe is vast and time is long, such overlaps are inevitable eventually. Both were correct in their own way. Coincidences are improbable, yet in a system as large as the cosmos, improbabilities happen all the time. The paradox is that what feels unique may simply be one of countless patterns that pass unnoticed. But perception matters as much as reality. For Venezuelans shaken by the quakes, September's timing was not abstract, it was visceral. The Earth's trembling felt like part of a larger story, especially when the sky itself seemed alive with omens. For astronomers watching atlases glow, the solar storm's timing raised scientific questions that could not be dismissed. For ordinary people scrolling through feeds of auroras, novas, and quake footage, the clustering looked like a plotline too neat for fiction. The power of September was not just in what happened, but in how it was experienced. A global sense that the pieces fit, even if the logic was elusive. The distinction between coincidence and correlation may never be fully resolved. Perhaps the quakes were purely geological, their timing with the solar storm and comet flare nothing but chance. Or perhaps subtle electromagnetic effects link space weather with seismic unrest in ways not yet understood. Perhaps Atlas's flare was just natural outgassing. Or perhaps interstellar objects really do carry properties that resonate with cosmic and terrestrial systems alike. What is certain is that September forced us to confront the limits of our understanding and the biases in how we interpret patterns. Coincidence comforts skeptics, correlation comforts seekers. Both, in their own way, are responses to the unknown. But sometimes, the boundary between them blurs. When multiple anomalies cluster in time, even scientists admit a need to look closer. September's lesson may not be whether the events were linked, but that the search for linkage drives inquiry forward. Without suspicion of correlation, we would never look beyond coincidence. Without caution against coincidence, we would drown in false patterns. In the end, September left us suspended between the two. Coincidence explains the events neatly, but unsatisfyingly. Correlation teases us with possibility, but demands proof we don't yet have. Perhaps the truth lies somewhere in between, in a universe where both random and resonant, accidental and meaningful, noise and signal. What matters most is the question itself. In asking whether September's anomalies were coincidence or correlation, we admit that the cosmos still surprises us. We admit that we do not have all the answers, and we admit, perhaps reluctantly, that sometimes the line between chance and connection is as mysterious as the green glow of a comet from another star. And so, the debate continues. Coincidence or correlation? The answer for now remains hidden. But the echoes of September remind us that the universe does not need our categories. It simply acts. And we, standing beneath it, are left to decide whether we are witnessing random noise or the first notes of a larger, still unfolding song. Whispers of ancient records. Long before satellites tracked solar storms, before seismographs measured the tremors of the Earth, humanity relied on memory carved into stone, painted onto parchment, and whispered from one generation to the next. In those records, natural disasters and celestial wonders often merged into a single story. A comet might blaze across the sky, and weeks later the ground would heave. Two events tied together in the minds of ancient peoples as cause and consequence. Whether coincidence or correlation, history is heavy with accounts that mirror the strange alignments of September 2025. And when Three-Eye Atlas flared green in the heavens just as Venezuela was struck by twin earthquakes, many felt as though they were witnessing not a new chapter, but the return of an old story humanity has told itself for millennia. In Mesopotamia, the earliest astronomer priests etched omens on clay tablets, part of vast collections known as the Enuma Anu Enlil. Among their most chilling entries were warnings that comets, hairy stars, or sudden bright objects presaged upheaval. Records describe great quakes, plagues, and the fall of kings coinciding with skyward anomalies. One tablet recounts how a greenish torch star appeared in the east, and not long after, the earth shook and the walls of Akkad fell. Whether literal or poetic, the association of comet and quake was sealed into the record as more than chance. China's meticulous chronicles offer even more striking parallels. For thousands of years, imperial astronomers tracked every eclipse, nova, and comet, recording them alongside floods, famines, and seismic disasters. In the Book of Han, a passage describes a star with a long green tail that appeared in the same season as a devastating quake that toppled cities along the Yellow River. Later dynastic texts repeat the refrain, "When the sky burned, the earth trembled." The mandate of heaven by which emperors ruled was believed to wobble when heaven and earth aligned in fury. A comet flaring during a quake was not coincidence but condemnation, a warning inscribed by the cosmos itself. The Greco-Roman world also blended comets and catastrophe. Pliny the Elder cataloged the strange shapes and colors of comets, noting that some were accompanied by earth tremors. Ancient historians wrote of earthquakes striking in tandem with celestial signs, sometimes green or blood-red stars streaking the skies. Livy, in his History of Rome, described years when the heavens burned with fire and the earth shook with unusual violence. To him, these were not random overlaps, but signs of imbalance in the natural order, events linked by forces humans had not yet grasped. Indigenous traditions across the Americas tell similar tales. Among the Maya, codices describe sky serpents and smoking stars as harbingers of destruction, often followed by quakes or floods. In Andean myths, the ground shakes when gods of the sky wage war, their weapons flashing as comets or fireballs. Even in North America, oral histories of First Nations recount great green stars that appeared before the ground cracked and waters shifted. These whispers, passed across centuries, suggest that human memory long ago wove a connection between cosmic anomalies and terrestrial upheaval. Medieval chronicles continued the pattern. In Europe, monks kept careful notes of cometary visitations. One 12th century text describes a comet of unusual color seen above England in the same year a great quake struck Antioch. Chroniclers debated whether the comet caused the quake or simply heralded it, but to them the sequence was more than chance. Similarly, in Japan, samurai-era records describe earthquakes rattling Kyoto soon after the appearance of a jade star, its light casting an unnatural glow over the capital. Over and over, the refrain is the same. A bright, often green star blazes, and soon the earth moves. Skeptics today dismiss these links as cultural projection, the human mind weaving story from coincidence. And yet, one cannot ignore how consistent the records are. Across civilizations separated by oceans and centuries, the same connection recurs, sky signs and earth tremors paired like twin notes in a song. Could this be nothing more than apophenia pattern-seeing run amok? Or could the ancients have noticed correlations too subtle for our instruments, too fleeting for modern science to prove? September 2025 revived those whispers with eerie precision. Atlas's green coma flared brighter in the same days Venezuela cracked under twin quakes. To the rational mind, this was coincidence. To those who remember history's echoes, it was resonance, the reappearance of an ancient pattern recorded countless times before. Just as Chinese astronomers linked green comets with seismic unrest, just as Mayan scribes wrote of smoking stars heralding ground shifts, modern observers saw the symmetry and felt it in their bones. The whispers of ancient records also speak to fear, a fear as primal as it is enduring. Earthquakes terrify because they strike without warning, unlike storms or floods. Comets terrify because they appear suddenly in the sky, untethered to predictable cycles. When both arrive together, humans instinctively weave them into a shared cause. Perhaps it is survival logic. If we link disasters, we can prepare for them. If comets foreshadow quakes, then watching the sky might save lives. Whether true or not, the belief itself carried power, shaping ritual and policy for centuries. Even the language of omens lingers. When journalists called Atlas the green sword in the sky, they echoed medieval chroniclers. When Venezuelans whispered that the comet was a sign, they joined the voices of Akkadian priests and Han scribes across millennia. History, it seems, has a rhythm, one in which cosmic and earthly upheavals are seen as one. Science pushes back, insisting on boundaries. Earthquakes arise from tectonic plates, comets from icy reservoirs around distant stars. The two do not interact, not in any measurable way. Yet science also thrives on anomalies, and ancient records are full of them. Could electromagnetic disturbances from solar storms triggered by the same cosmic alignments that brighten comets play some role in seismic unrest? Could humans have witnessed subtle synchronicities that instruments now dismiss as noise? What is undeniable is the persistence of the pattern. Across cultures, epochs, and languages, humanity has recorded the same refrain: when the heavens blaze green, the earth stirs. September 2025 added its verse to that song. Atlas, emerald against the stars, flared as the Venezuelan crust fractured. Perhaps it was chance, perhaps it was correlation, but to the whispers of ancient records it was continuation, a reminder that humanity has seen this alignment before and will likely see it again. Whether we interpret those records as superstition or insight is less important than the fact that they endure. They speak to an instinct older than science itself, to see the world as one connected whole, sky and earth bound by invisible threads. September's events reawakened that instinct, forcing us to ask whether the ancients were only dreaming or whether they glimpsed truths we have forgotten. And so the whispers grow louder. Each earthquake paired with a comet, each green star recorded beside trembling ground, each myth retold across generations, all echo through September 2025, when once again earth and sky seemed to move in tandem. For a world saturated with data, it was a humbling reminder. Sometimes the old stories still fit, sometimes the ancient whispers still resonate, and sometimes, when we least expect it, history leans close to remind us that perhaps we are not the first to wonder if the universe has patterns hidden in its storms, its quakes, and its green stars blazing in the night. The next proving ground for weeks, 3i Atlas has been the subject of speculation, awe, and unease. Its emerald glow, oversized coma, anti-tail, and inexplicable surges in brightness have made it one of the most baffling interstellar objects ever observed. The Venezuelan twin earthquakes of September, paired so uncannily with its flare and the sun's storm, cast it not only as a celestial curiosity, but as a symbol of uncanny timing. Yet for all the debates, whispers, and theories, there remains a crucial question: where will we find the next round of answers? The proving ground for this mystery is already on the horizon, and it lies with Mars. Atlas's trajectory is no ordinary pass through the solar system. After brushing near Earth's orbital neighborhood and dazzling telescopes worldwide, it is set to sweep closer to Mars than to any other planet. That encounter, though brief, is being billed as the next great opportunity to test whether the anomalies surrounding Atlas are products of coincidence or signs of something more. Cameras, spectrographs, and orbiters around the red planet are poised to catch the visitor in unprecedented detail. If Earth's observatories gave us puzzles, Mars may give us clues. The importance of this moment cannot be overstated. With Oumuamua, humanity had no chance. By the time it was spotted, it was already leaving. Borisov gave us more data but fit the mold of an icy comet well enough to satisfy most scientists. Atlas is different. It's anomalous, it's accessible, and it's giving us time to prepare. Mars, with its fleet of orbiters and rovers, represents the first chance to observe an interstellar object not just from afar, but from multiple vantage points around another planet. The proving ground is not only about what we'll see, it's about whether we'll finally separate speculation from evidence. What exactly might we learn? For one, the close pass will test theories about Atlas's unusual brightness. If its glow is truly the result of exotic chemistry, Martian orbiters equipped with spectrometers may detect emissions invisible from Earth's surface. If the brightness is instead due to structural peculiarities in its dust grains, high-resolution imaging may reveal filaments, clumps, or strange reflections that break the rules of normal cometary physics. And if, though most scientists hesitate even to say it, the brightness is the result of something engineered, some controlled emission, then Mars may catch the signature. For skeptics, this encounter will close the case. For seekers, it may open the door wider. Mars also presents a unique stage for impact speculation. Some worry, though most dismiss, that fragments of Atlas could strike the red planet. If they did, the results would be dramatic: dust clouds, localized quakes, and perhaps chemical changes in the thin Martian atmosphere. While the risk is considered small, the mere possibility has fueled excitement. For astrobiologists, even a harmless atmospheric interaction could be revelatory. If Atlas carries organic compounds or unusual volatiles, Mars might serve as the testing ground where those substances reveal themselves, preserved in the dry air of the planet in ways Earth's environment would never allow. There is precedent for comets playing such roles. In 1994, fragments of comet Shoemaker-Levy 9 slammed into Jupiter, creating fireballs and scars in the planet's atmosphere that lingered for months. That event was a proving ground for planetary science, back showing how fragile even giant worlds can look under cosmic bombardment. If Atlas interacts with Mars in any way, through dust, fragments, or even just the play of light against its thin skies, it could become Shoemaker-Levy for the 21st century, except with an interstellar twist. The proving ground is not only physical, but psychological. Humanity's fascination with Atlas has grown precisely because of its timing, its apparent entanglement with September's upheavals. Skeptics call this projection, but for billions who felt the tremors, saw the auroras, or read about novas blazing above, the narrative is too tight to ignore. Mars, then, becomes more than a planet with instruments. It becomes a stage on which this story continues. If Atlas passes uneventfully, perhaps it will cool the fever of speculation. If anomalies persist, however, the story will deepen, and the whispers of ancient records will grow louder. Space agencies are acutely aware of this. Already, NASA, ESA, and other institutions have quietly reprioritized observation schedules. The Mars Reconnaissance Orbiter is expected to capture long-range imagery. China's Tianwen-1, with its high-resolution camera suite, is positioned to track the visitor's coma and tail. Even rovers may be tasked to turn upward, their cameras calibrated for atmospheric effects. It is the first time in history we will watch an interstellar visitor not just from one world, but from two. The proving ground, in that sense, is also a mirror. How Earth and Mars together perceive this traveler may redefine how we understand interstellar phenomena. There are, of course, those who suggest that even Mars will not settle the matter. They argue that if Atlas is more than natural, its mysteries may elude every instrument, revealing just enough to provoke, but never enough to explain. Such thinking borders on the mythic, casting Atlas as a trickster in the cosmic drama. Yet even here, the proving ground has value. Science advances not only by answering questions, but by refining them. If Mars cannot solve Atlas, it will at least tell us what questions to ask next, what instruments to build, what missions to prioritize, and what models to abandon. Culturally, the proving ground also carries weight. Ancient peoples once saw comets as omens tied to rulers, empires, or divine will. Today, with Mars as our second set of eyes, we are in effect updating that ancient instinct with modern tools. Where scribes once recorded a green star and the Earth shook, we now record spectrographs, light curves, and orbital alignments. The difference is scale, not essence. The human drive to connect sky and ground remains. Only now we aim to prove or disprove those connections with data. Mars represents that shift, the ancient impulse refined through modern science. There is a deeper, more unsettling possibility. If Mars observations reveal nothing unusual, skeptics will claim victory, but pattern hunters will not let go. They will argue that Earth was the stage, not Mars, and that Atlas's role was to mirror our planet's unrest, not to perform tricks for instruments elsewhere. In this interpretation, the proving ground is not just Mars, but humanity itself, our minds, our cultures, our instinct to weave coincidence into meaning. The real test is whether we can separate what the universe is doing from what we are projecting onto it. Still, for most, the proving ground is literal. The red planet will soon stand between us and the void, catching Atlas in its gaze. It is here we will learn whether its anti-tail is mere dust or something stranger, whether its brightness is exotic chemistry or engineered emission, whether its anomalies dissolve under scrutiny or deepen into riddles. Whatever the outcome, Mars will mark the turning point. Either Atlas fades into history as a misunderstood comet, or it cements its place as one of the most extraordinary objects humanity has ever encountered. As September fades into memory and anticipation shifts to the future, one truth becomes clear. The story of Atlas is far from over. Its next proving ground lies not in the whispers of ancient records, nor in the fears of coincidence, but in the cold skies above Mars. And as our instruments focus and the world watches, we may finally step closer to the answer that has haunted us since this Emerald Wanderer arrived. Is Atlas just another visitor from the stars, or is it something altogether more profound? Whatever Mars reveals, the proving ground ensures one thing. Atlas will no longer be speculation alone. It will be data, evidence, and perhaps revelation. And when the cameras send back their images, humanity will look again, not just for the comet, but for itself, reflected in the mysteries we dare to chase. The bigger pattern emerging as September's chain of events faded into memory. The Venezuelan twin earthquakes, the solar storm, the novas flaring in nearby constellations, and the emerald beacon of 3I Atlas burning brighter than models could explain, something remarkable lingered. It wasn't just the shock of each individual event, it was the way they seemed to line up, like beads strung on an invisible thread. To scientists, the challenge was to disentangle the noise from genuine signal. To the public, the allure was simpler. There felt like a pattern here, one too precise to ignore. Human history is full of moments when isolated anomalies coalesce into a larger narrative. The eruption of Krakatoa in 1883 was tied by many to strange sunsets and bizarre weather worldwide. The Lisbon earthquake of 1755 was interpreted by philosophers as proof of divine judgment, reshaping Enlightenment debates about God and reason. More recently, the 2011 Tohoku earthquake and tsunami, coinciding with solar storms and volcanic unrest, was folded into modern discussions of synchronicity. In every case, when the improbable stacks too neatly, humans instinctively begin to ask, what is the bigger pattern here? In the story of 3I Atlas and September's upheavals, the pieces seem to fall into place with unsettling rhythm. Earthquakes, rare in their double strike, hit precisely as geomagnetic disturbances peaked. The comet's brightness surged during the same window, its anti-tail pointing sunward like a luminous blade. Two novas blazed in constellations long associated with omens in ancient records. Each event, considered separately, might be written off as coincidence. Together, they painted a picture of alignment, as though different layers of reality, the ground, the sky, the stars, had briefly tuned to the same frequency. Scientists resist such narratives. Their training demands boundaries. Earthquakes are geological, comets are astronomical, solar storms are astrophysical. Correlation is not causation. But even among researchers, there was unease. Reports of ionospheric disturbances above South America prior to the Venezuelan quakes hinted at interactions between the crust and the charged upper atmosphere. Space weather specialists noted that Atlas's flare was unusually synchronized with the solar storm's timing. Astronomers conceded that two naked-eye novas in the same season were rare. None of this proved connection, but neither did it allow the luxury of easy dismissal. What made the bigger pattern so compelling was its resonance with history's whispers. As we have seen, ancient chronicles often recorded comets and earthquakes in the same breath. The Chinese, the Maya, the Romans, the Mesopotamians, all saw the heavens and the earth as linked. Perhaps they were only seeing patterns where none existed. Or perhaps they had glimpsed correlations we have yet to understand. September 2025 felt like their records come alive again. To modern minds, the pattern echoed less like superstition and more like déjà vu, as though we were reliving a script written across centuries. From a psychological perspective, this instinct to assemble patterns is inevitable. Humans abhor randomness. When confronted with chaos, we weave storylines to tame it. But sometimes patterns are not imagined, they are real. The discovery of planetary orbits, the mapping of DNA, the understanding of plate tectonics, all began with noticing patterns others ignored. The bigger pattern of September may yet dissolve under scientific scrutiny. But it may also represent the first glimpse of connections science has not yet learned to measure. One of the most intriguing possibilities raised by pattern hunters is that of resonance. Could the Earth, the Sun, and interstellar objects like Atlas be linked through subtle energetic couplings? Earthquakes, after all, release electromagnetic pulses. Solar storms bombard the magnetosphere. Comets shed charged particles that interact with solar winds. What if, during rare alignments, these phenomena resonate with each other, amplifying effects in ways not yet modeled? The Venezuelan quakes might not have been caused by Atlas or the solar storm, but perhaps the timing reflects a resonance event where multiple systems vibrated in harmony, their peaks coinciding. If so, the bigger pattern is not mystical but systemic. It would mean our solar system is less a collection of isolated parts and more a web of interdependent rhythms. Earthquakes may be geological, but they do not exist in a vacuum. Solar storms may be astrophysical, but their impacts ripple across the magnetosphere and ionosphere. Comets may be cosmic vagabonds, but their volatile emissions interact with the sun's breath. September 2025 may have been a moment when these rhythms aligned, not by magic, but by natural harmonics we have not yet charted. The allure of the bigger pattern extends beyond science. Culturally, humans long for meaning in chaos. For Venezuelans, the quakes were not just disasters, but part of a story larger than their borders, a cosmic drama in which their suffering felt tied to the heavens themselves. For global observers, the clustering of anomalies fed existential questions. Are we truly isolated in our struggles, or are we part of a universe that speaks in patterns, however faint? For some, the pattern was divine. For others, it was statistical. But for all, it was haunting. Media narratives only amplified this sense. Headlines framed September as the month the cosmos turned, or the sky and earth in conversation. Documentaries replayed footage of swaying skyscrapers beside images of auroras and glowing comets, creating visual montages of synchronicity. Even skeptics found themselves unsettled by the sheer drama of it all. The pattern, whether real or imagined, had already imprinted itself on collective memory. But what if the bigger pattern is not confined to September? What if we are only noticing the first notes of a longer symphony? Pattern hunters point to other recent anomalies: volcanic unrest, sudden weather extremes, even spikes in atmospheric phenomena like sprites and jets. Are these part of the same tapestry? Could Atlas be only one piece, a catalyst that illuminated a larger cycle of resonance? If so, the proving grounds of Mars, the sun's continuing storms, and Earth's restless crust may reveal more alignments to come. Critics warn against slipping into fatalism. Patterns can inspire awe, but they can also breed fear. Ancient cultures sometimes collapsed into panic when comets and quakes coincided, convinced of impending doom. Today, the danger is similar, turning coincidence into prophecy, data into omen. Yet, there is also opportunity. If patterns exist, understanding them could transform science, giving us new tools to predict quakes, solar disruptions, or cosmic interactions. The line between fear and discovery may rest on how we interpret the bigger pattern. Ultimately, the events of September left us with a paradox. Coincidence explains them cleanly but leaves us unsatisfied. Correlation tantalizes but lacks proof. The bigger pattern emerging is neither wholly one nor the other. It is both possibility and projection, fact and story, data and myth. What unites all interpretations is the recognition that something about September felt orchestrated, even if only by the randomness of a universe vast enough to produce patterns without intention. Perhaps that is the final lesson. The bigger pattern may not be evidence of cosmic design or hidden forces. It may simply be a reflection of ourselves, our longing to belong to something larger, to find meaning in chaos, to connect the trembling of the ground with the shimmer of the skies. Yet, even if the pattern is projection, it has power. It compels us to look harder, question deeper, and admit that the universe still holds mysteries beyond our grasp. And so, as we await the next chapter, Atlases pass by Mars, the sun's continuing flares, the Earth's next tremor, we carry with us the memory of September, a month when sky and ground seemed to move in unison. A month when whispers of ancient records echoed anew. A month when coincidence blurred into correlation, and a bigger pattern seemed to emerge. Whether that pattern is real or imagined, it has already reshaped how we see ourselves. Not as observers standing outside the universe, but as participants woven into its rhythms, however mysterious, however fleeting.